Now we have to calculate the covariance that is associated with security A and security B. Now here states of economy, probability factor are given in the question. We calculate earlier the mean deviation associated with security A, mean deviation associated with security B. These are to be plotted here. This is the mean deviation of security A, this is the mean deviation of security B. If we multiply these two, then we will get the joint deviation, and this, if this joint deviation is to be multiplied with the probability factor, and we then after multiplication of the probability factor with the joint deviation, then we will get the result of covariance associated with both security A and security B. Here for states of economy 1, that means nature of states of 1, here the joint deviation is -8 into -14, then it will come to 112, and then if we multiply this joint deviation with the probability factor, then the result comes to 11.2. Here the joint deviation for the second states of nature is -3 into -6, so it comes to 18, and if we multiply this 18 with the probability factor of 0.3, the result comes to 5.4. For third states of nature, here the joint deviation comes to 2 into 4, that means 8, and if this 8 is multiplied with the probability factor, then it comes to 4. For fourth state of nature, the joint deviation is 7 into 12, that means 84, and if this 84 is multiplied with the probability of 0.1, then the result comes to 8.4. So the average deviation, average joint deviation, which is calculated after multiplying the joint deviation with the probability, comes to 29%, and it is called covariance. Now what is covariance? Covariance is the average joint deviation associated with both security A and security B. So this is the risk for holding both the securities together, and it is in absolute term. So for holding both security together, that means security A and security B together, there will be risk of 29%. Now we have to calculate correlation coefficient. What is correlation coefficient? We know that correlation coefficient, formula for correlation coefficient is COV divided by standard deviation of security A into standard deviation of security B. Now this formula, we use this formula in semester 1 in chapter joint distribution. Now recall this, we know that correlation coefficient associated with security A and B is covariance of security A and B divided by standard deviation of return of security A into standard deviation of return of security B. Now here we have the covariance of 29%, standard deviation of return from security A is 4%, standard deviation of return from security B is 7.27%. So here the result of correlation coefficient comes to 0.997. Now what does it imply? Now correlation coefficient is risk associated with both security A and security B, but the result are given in relative term. Here covariance is also the risk for holding two security together. It comes to 29%, but this result is in absolute term. And whenever we calculate correlation coefficient, it is also a risk associated for holding security A and B together, but that result is given in the relative term. And what does it mean? It means that this is COV AB is holding both security together, and it is 29%. If we hold the security separately, then the total risk comes to 4% into 7.27%. It is 29.08%. So if we hold security A and security B together, the risk comes to 29%. If we hold this security separately, then the total risk comes to 29.08%, and here the correlation coefficient comes to 0.997. Now what does it imply? What is correlation coefficient? It implies that if return of security A increase by 1%, return of security B will increase by 0.997%. Return of security, if return of security A is decreased by 1%, return of security B will decrease by 0.997%. So here the correlation coefficient is indicate the movement associated with one securities with other, and here since the correlation coefficient of security A and B gives a positive result, that means it greater than 0, here we can say that security A and B are correlated positively. Here if return of security A is increased by 1%, return of security B will also increase, and it will increase by 0.997%. If return of security A is decreased by 1%, then return of security B will also decrease, and it will decrease by 0.997%. So here security A and security B is related positively. So now we have to calculate the last answer of the last question. The last question was that what is the expected return and risk of the portfolio in which A and B have weight of 60% and 40%. Here we have to calculate the portfolio return. Expected return of the portfolio is the summation of the expected return of individual security with their associated weight. So here the formula of expected return of the portfolio, that means ERP, is WA into ERA plus WB into ERB. Here WA is given in the question, it is 0.60. Expected return of security A is calculated earlier, it is 13%. So it is 0.60 into 13%. Similarly WB, that means weight of security B, is also given in the question, it is 0.40, and expected return of security B is 14%. So here WB into ERB is 0.40 into 14%. Now the expected return of portfolio comes to 0.60 into 13% plus 0.40 into 14%, and here the expected return from the portfolio comes to 13.4%. So here that is the expected return that is to be generated from the portfolio in which security A is held in a weight of 60% and security B is held in a weight of 40%, comes to 13.4%. Now the associated risk of the portfolio is to be calculated. Now here the risk of the portfolio is to be calculated first in the terms of variance. Now the variance of portfolio, that means sigma p square, is formula of variance of two asset portfolio is WA into sigma A whole square plus WB into sigma B whole square plus 2 into WA into sigma A into WB into sigma B into RAB. If we eliminate this factor, then here it is A square plus B square plus 2AB. It is A square, WA into sigma A whole square, it may be taken as A square. WB plus sigma B square is to be taken as B square plus 2AB, and with this we have to attach RAB. RAB means the correlation coefficient between two securities. So at the time of recall the formula, at the time of remember the formula, memorize the formula, if we use this tactics, that means sigma p square is nothing but A square formula of A plus B whole square, A square plus B square plus 2AB, and then after writing this formula, if we attach the correlation coefficient with this, then we will get the formula of the variance. Now we have to put the value associated with these figures. Now here WA is provided in the question, it is 0.60, sigma is calculated earlier, it is 4, so WA into sigma A whole square is 0.6 into 4 whole square, WB into sigma B square is 0.4 into 7.27, WB is provided in the question, sigma B is calculated earlier, and it is comes to 0.4 into 7.27 whole square. Now 2 into WA into sigma A, WB into sigma B, RAB is calculated earlier, it is 0.997, and here the variance of portfolio comes to 28.14%, and here the risk associated with the portfolio is the root of the variance, and it comes to 5.30%. So here the risk associated with two asset portfolio consisting of two security A and B is 5.3%. Whenever we have to calculate the risk of two asset portfolio, we have to use this formula. After calculation of the variance of the portfolio, we have to calculate the standard deviation of that portfolio by making root of the variance, and then we will get the result of the risk associated with portfolio. Here it comes to 5.30%. Now if we look carefully here, the return associated with security A was 13%, risk associated was 4%, return associated with security B was 14%, risk associated with security B is 7.27%. Whenever we are constructing the portfolio, here risk and return are related positively. That means the security giving the lower return have lower risk, security giving the higher return giving the higher risk. Now after constructing portfolio, here a rate of return from the portfolio, expected rate of return from the portfolio comes to 13.4%, which is more than the minimum return portfolio, minimum return securities, that is security A. Here the return from security A was 13%, but portfolio return is more than 13%, 13.4%. Now the risk of the portfolio comes to 5.3%. 5.3%. Here the risk comes to 5.3%, which is less than the higher risk portfolio, that higher risk asset of security B, which was 7.27%. So here risk of the portfolio comes to 5.3%, which is lower than the higher risk asset consisting in the portfolio, and return of the portfolio comes to 13.4%, which is more than the lower giving the lower return asset consisted in the portfolio, that means security A. So here by constructing portfolio, here the investors will get the diversification benefit in terms of reducing the risk to some extent and increasing the return to some extent. Here the rate of return of the portfolio comes to 13.4%, and risk of the portfolio comes to 5.3%.